Want to know how brand new cloud apps talk to ancient, fragile computers without breaking them? Today, we will learn the magic translations and digital elevators that connect the oldest machines in the world to the newest technologies. Many of the computers that run our banks or power our hospitals were actually built decades ago. Even though they're old, they are incredibly reliable and still do their jobs perfectly every single day. Because these systems are so old and so important, there is a very strict rule for modern programmers. You can never change the original code. You have to leave it exactly as it was found. To get information in or out, you have to use the original connection point that was built into the system long ago, something experts call a proprietary interface. Think of that proprietary interface as an antique wind-up toy without a modern battery. Instead, it has a very specific star-shaped socket. To make it move, you need a specialized winding tool. Nothing else will fit to make those old gears turn. When you put this delicate toy next to a modern smartphone or a high-tech server, it looks completely out of place. It has no way to understand the digital signals flying around it. If we don't find a way to help these old machines, they become isolated. They would be full of important information, but totally cut off from the rest of the modern world. Today, modern apps communicate on a wide, glowing digital highway. This road, where all the new digital toys talk and play together, is called the standard exchange bus. Our little wind-up toy can't drive on this highway. It doesn't have the wheels or the speed to keep up with the fast-moving traffic. To get the toy onto the highway, developers build a special layer of software called a legacy wrapper. This diagram shows the connection in action. The legacy application at the top reaches down through its proprietary interface and plugs directly into the wrapper box. You can imagine this legacy wrapper as a high-tech remote control suit that snaps right around the old toy. Inside the suit, tiny robotic hands perfectly turn the toy's star-shaped socket. The suit does all the work, so the fragile old toy never has to be modified or forced to change. The outside of the suit speaks the language of the highway perfectly. It takes the toy's old data and translates it so the other apps on the standard exchange bus can understand it. This allows an ancient machine to safely share its information with the newest apps, keeping the old code safe and sound inside its protective shell. If we look up from the highway, we can see a towering skyscraper. This is how we organize the code inside a single system. Code is stacked vertically in floors, a design called a multi-level layered architecture. Each floor has a specific job. Floors are isolated from each other. Workers on one floor only talk to the floor directly below them, keeping everything organized. Suppose the top floor has a big task that needs finishing. They write the details on a request form and put it into a magic elevator to send it down. This downward request is what we call a downcall. Once the request is sent, the top floor doesn't have to worry about it anymore. They can sit back and drink hot cocoa while the lower floors handle the heavy lifting. Down in the basement, workers finish the job. They put the final answer into the elevator and ring a bell. This alert traveling back up is an upcall. It's the signal that tells the top floor the data has arrived. By using this elevator system, we can build massive, complex systems that stay perfectly tidy, because every floor only worries about its own special task. Next time, we will learn how master builders use pre-built toy skeletons when we explore application frameworks and creational design patterns. Think of those as the ready-made blueprints we use to build new digital objects. Thank you so much for watching.